This lesson, we're going to discuss chemical reactions. At the end of this video lesson, you should be able to identify the signs of chemical change and write chemical reactions in words and equations. If you are a Marvel fan, or if you're familiar with the bleep, you know by now that there was a significant change that happened on a huge percentage of the population which vanished after Thanos snapped. They reappeared. Can something that has been gone for so long, or even for a short period of time, come back to its original form or state? When ice melts, ice becomes water. Since water can still be frozen to bring back ice, although it may not be back to its original physical form, this process is said to be reversible. Water when boiled becomes water vapor through the process of evaporation. This can be reversed through the process of condensation. Although of course, it will not be hot water. Burning paper is something that we should always be careful with. Not because its fire is dangerous, but because important papers like documents, photos, and even money turn into ashes they burn. There is no process to turn back the ashes to the original form of paper. Thus, this process is definitely not reversible. Aside from avoiding oil splashes, you must be careful when cooking an egg in a way that you must know what cooking method of egg you want. A cooked sunny-side up egg cannot be reversed to a raw egg for you to scramble it or make it an omelette. Hence, this is not reversible. However, changes in matter are not and should not be boxed on the classifications of whether they are reversible or irreversible. Rather, changes in matter should be classified as the impact of the change. Specifically, we are looking at the changes in the matter's composition and not solely on its form. Changes in matter may be classified as physical changes or chemical changes. Physical changes are changes which happen on its physical form or structure. Changes may be totally significant from the original, but when the composition or structure in the atomic level will be observed, there are no changes evident. For example, boiling water to form water vapor and melting ice to form cold water are physical changes. There may be changes in the physical state of water, but the composition is still 2 hydrogen atoms for every 1 oxygen atom. On the other hand, chemical changes are changes in the identity of the original substance. The physical states of the substance may or may not change, but deep inside their atomic structures, their compositions have changed. For example, burning paper changes the composition of paper to ash. These are 2 different things. On the other hand, for frying an egg is still an egg after it has been fried. However, the peptide bonds of the egg would have been broken as it is heated in oil, making its chemical composition different from raw egg. Of course, we will not be able to see the atomic or molecular composition of matter, but there are signs that may tell us that a chemical change is occurring. Chemical change occurs when the color of matter changes. This is because color is a property of matter that is a result of its composition. For example, the green color in leaves is due to the pigment chlorophyll. In fall, the leaves turn into yellow to orange as the chlorophyll pigment breaks down. Another sign is change in odor. Changes in the substances present in matter may yield to the production of compounds that produce pleasant or unpleasant odor. For example, foul odor in food is an indication of spoilage. This is a chemical change. Next is effervescence or evolution of gas. This includes the formation of bubbles or even smoke or steam. This is again due to the reaction of the initial substances in a system. An example of this is when oral tablets are dissolved in water to release gaseous substances. Another sign of chemical change is precipitate formation. This happens when 2 liquids are mixed and a solid called a precipitate is formed. This is another evidence that a new substance is formed during a chemical reaction. Another important thing to consider in chemical changes is that there is a transformation of energy as the reaction proceeds. Energy in chemical change may be classified as endergonic or the absorption of energy, or exergonic or the release of energy. These 2 terms are general terms for the transformed energy since there are many types of energy. But if we are dealing with energy in the form of heat, we call endergonic reactions as endothermic, and exergonic reactions as exothermic. Endothermic reactions require heat to proceed. On the other hand, exothermic reactions give off heat as they proceed. For example, in melting ice, although not a chemical change, still involves energy transformation. This is because energy transformations are present on both physical and chemical changes. For ice to melt, it needs to be exposed to a higher temperature, therefore absorbing heat, an endothermic process. On the other hand, burning charcoal gives off heat as the process continues. Thus, this is an exothermic process. The signs of chemical changes that we have just discussed are the bigger picture of what we know as chemical reactions. This means that chemical changes accompany chemical reactions. Or in other words, without chemical changes, chemical reactions will not proceed. Chemical reactions occur when bonds between atoms are broken and created to form new substances. Atoms of elements may be joined together as bonds are created based on the properties of the atoms. They may also be broken down. In either case, new substances are being formed. Thus, a chemical reaction is described as the process in which a reactant or a group of reactants interact with each other and with other factors to yield new substances, which we call the product or products of the reaction. An important feature of chemical reactions is that the reactant side will never be the same with the product side since new substances are being formed in chemical reactions. Chemical reactions are usually written in equation form. Different symbols are used in writing equations of chemical reactions. A plus or addition sign means that there are multiple reactants or products in the reaction. The reactant and product side may be composed of only one substance, given that the other side is not a single substance. An arrow pointing to the right means yield or the reaction proceeds from the reactant side to the product side. A double-headed inverse arrow means that the reaction is reversible. This means that the product side may also lead to the formation of the reactants, given that the conditions of the reaction are met. Next is a triangle sign placed above the arrow sign. This means that heat or electricity is used to proceed with the reaction. The physical states of matter can also be written as subscripts in the equation. S means solid, L means liquid, G means gas, and AQ means aqueous or that the substance is dissolved in water, but water is not written as a separate reactant or product. Let us look at some examples of writing equations of chemical reactions. Solid iron 3 oxide and carbon monoxide gas produce iron metal and carbon dioxide gas. It will be helpful for us to identify each element or compound that will be used in the reaction. So we have solid iron 3 oxide and carbon monoxide gas for the reactant side, and iron metal and carbon dioxide gas for the product side. We can already put the yield sign to separate the reactant side from the product side. We're just going to write the names of the following substances based on the rules on nomenclature of compounds. We're going to put the addition sign to denote that more than one substance is present for each side. Lastly, we're going to write the symbols for their physical states. There would be no problem for iron 3 oxide, carbon monoxide, and carbon dioxide because the states are explicitly stated. For iron, since it is a metal, it is considered a solid. All metals except for mercury are solid at room temperature. For the last example, carbonic acid, when heated, decomposes into carbon dioxide and water. Again, it will be a big help for us to identify the substances involved. But be careful because sometimes the product side is mentioned first. The reaction proceeds when carbonic acid is heated. This means that we write the symbol for carbonic acid and followed by an arrow with a triangle above it since heat is involved. And we can now write the rest of the equation, which is the product side. Since there are two products, we need to put a plus sign. Now, if the state is not mentioned, it is alright to not indicate the signs most of the time. However, for practice purposes, we're going to write the signs even if the states are not mentioned. Acids are considered aqueous substances, thus we use AQ. Carbon dioxide is gaseous, and lastly, water here is considered liquid. It only becomes gaseous when it is indicated that it becomes a vapor. Now, to conclude the lesson, let us review the following key points. Chemical changes occur in substances when their composition changes. These occur in chemical reactions. Chemical reactions occur when the bonds of substances are created or broken to form new substances. And lastly, chemical reactions have two important components, reactants and products. And that ends our discussion on chemical reactions.